Hello everybody, this is Mr. McNair, and this is a video on the 2008 OGT questions from the Data Analysis and Probabilities section. What I would suggest you do is go ahead and take a moment and read through the tips so that you can properly use these videos. Alright, number 3. A restaurant manager is planning a survey to determine which 3 desserts are most preferred by his customers. Which sample would best represent the customers at the restaurant? Now, when you're doing problems like this, I would suggest that you read through the choices and you start eliminating the choices that don't make sense. Now, whenever you're doing a survey or a sample, you always want the people that you sample to be representative of the entire population. So, let's look at choice A. Survey all children who enter the restaurant. Well, unless you're only serving children, children are not going to be representative of everybody that comes and eats at the restaurant. B. Survey all customers over 50 years old for 1 week. Well, once again, unless you're serving only people over 50, then that's not going to be representative of the entire population. What about the people that are in their 30s and their 40s and the kids? All right, C. Survey all of the men that come into the restaurant for 1 week. Once again, if you're only serving men, that would be great, but most likely not. So that's not representative. What about the females? All right, D. Survey every 5th customer that enters the restaurant for 1 week. Now this could be representative of the entire population because it's not biased. It doesn't take into account age. It doesn't take into account gender. So this one you can actually use and be representative of the entire population. Alright, let's go to number 6. The graph shows the total sales per year for the X300 and X400 speakers produced by an audio manufacturing company. The question says, the manufacturer plans to discontinue the X300 speaker when the total sales for the X400 speaker are greater than the total sales for the X300 speaker. Based on the trend in the graph, what is the earliest year that the sales of the X400 speaker will be greater than the sales of the X300 speaker? So, what I would suggest here is, first of all, you kind of want to learn some terminology. When they say things like trend, based on the trend in the graph, that means that's just kind of like based on the pattern that's going on so far. So here you can look at the trend in the graph, like for the X300, and if you kind of connected these with a straight line, like use your calculator or a straight edge or whatever they have at the test for you to use, and go ahead and connect it with a straight line, and you can see the trend that's going on there. Alright, same thing with the X400 speakers. If you connected the dots with a straight line, pretty much you're doing a line of best fit going through the center of the data. Alright, so that would be about the trend of the graph. Okay. Now, it says based on the trend in the graph, what is the earliest year that the sales of the X400 speaker will be greater than the sales of the X300? Well, let's look at year 2000. At year 2000, X300 is still greater, so not then. Let's look at year 2003. Here, X300 still greater, so not there either. Let's look at 2006. Finally, the X300 is lower than the X400. The X400 is finally came above. So, in 2006, the X400 speaker will be greater than the X300 speaker. Okay? Alright, let's move on. Number 8. One style of jacket comes in 3 sizes, small, medium, and large. These jackets have either buttons or zippers. The jackets are available in 5 different colors. How many different combinations of this jacket are available? You could do this problem in 2 different ways. You could either make a tree diagram, or the fastest way is using what the principle called the counting principle. And the counting principle says that when you're trying to find the number of combinations of objects, you can actually just multiply the number of choices you have together. So here we have choices for sizes. You have choices for buttons and zippers. And then you have choices for colors. Alright, so that being said, you have a choice once again for a size, you have a choice for button and zippers, and you have a choice for colors. Well, how many choices do you have for sizes? Well, you have small, medium, and large, so there's 3 there. How many choices do you have for buttons and zippers? Well, buttons and zippers. There's 2 choices, either buttons or zippers. And then it says you have 5 different colors. Now, in the counting principle, all you have to do to find your answer is multiply all of your choices together. So 3 times 2 times 5. 3 times 2 is 6. 6 times 5 is 30. So there's a total of 30 different combinations of this jacket. Okay? Let's move on to the next question. Number 12. Mirachelle picked a colored cube from a bag of cubes, recorded the color, and returned the cube to the bag. She did this 10 times. The table below shows the color of each cube as it was selected. Now, it says using the information from the table, how many times would a yellow cube be expected in 30 picks? So let's look at the yellow choices. All right, so the yellow cube was picked here, 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 and here. So there's a total of 4 times out of the 10 times that we picked a yellow cube. Now, you could do this problem in many different ways. I'll cover a couple of them. 4 out of 10, some students will say, well, that's like having 8 out of 20 or having 12 out of 30. They just added 4 each time and added to the numerator and added 10 each time to the denominator. Okay, so that's one way you could do it. I think that a lot of students would look at this problem and say, okay, well, 4 out of 10. That's the same as a certain number out of 30. And they can set up a proportion. And to solve this proportion, you would just cross multiply. 4 times 30, that is 120. And 10 times x, that equals 10x. And then we would solve for x by dividing by 10 on both sides. So we would get x equals 12. Alright, so the answer here is 12, and both of our answers in both methods, we got 12 in both of those. Alright, so that's 2 ways that you can do the problem. You probably can find some other ways also. Alright, number 15, weekly salaries of the employees at a local video store are shown in the table. What is the mean weekly salary at this video store? Remember, to find mean is the same thing as average. And you find the mean or average by taking the sum and divided by the number of total entries. Okay? Now, in this problem, you have 1 person making 1,000, you have 2 people making 500, you have 4 people making 350, you have 8 people making 120, and you have 6 people making 80. Now, you could technically write all of this out and say, okay, well, and I'll show you actually. You got 1 person making 1,000, then you have your 2 people making 500, you have your 4 people making 350, you've got all those people making 120, you got 6 people making 80, and add it all up and get 4,840. And then here you also see that there's a total of 21 people. Alright, each one of these represents an individual. Okay, so there's a total of 21 of them and so on. So you could take that 4,840 and divide it by 21. Okay, and when you do that, 4,840 divided by 21, I'll just pull up my calculator here. You get $230 or 230.47, so we'll round that up to 0.48. So that's 230.48. So the mean weekly salary is $230.48. Now, another way that you could have done this problem is you could have said, all right, instead of actually having to write those all out, you could technically go to your calculator and say, all right, well, we have 1 person making 1,000, plus you have 2 people making 500. All right, let's go back to the problem again. And we have 4 people making 350. So plus 4 people that make 350. And then it says we have 8 people that make 120 and 6 people that make 80. So 8 people that make 120 plus 6 people that make 80. And once again, that comes out to 4,840. Now from there, you'd be able to look and say, okay, well, how many people did we actually have? Well, 1 plus 2. Let me make sure I write this out here. So 1 plus 2 plus 4 plus 8 plus 6. That's a total of 21 people. So you would do the 4,840 divided by 21 people, which still comes out to be $230.48. All right, great. Number 18, the graph shows the percent of the total votes cast for each of the 4 candidates in Andersonville's city council election. If 2,542 people voted in this election, about how many votes did Lango receive? Well, let's look at Lango. Here's Lango's votes right here. All right, and this is the percentage that he got in the election. Now, we can note that he didn't quite get 20%. He's below 20. He's above 15. It actually looks like he's a little closer to 20 than he is to 15. So you can kind of round and estimate here. I'm going to round and say it's about 18%. All right, so we need to know what 18% of the total vote is. Well, let's change this fragment into a mathematical expression. 18%, let's change that to a decimal. That'll be 0.18 of, usually means multiplication in mathematics, and the number of people that voted in the election was 2,542. So if we type that in our calculator, 0.18 times 2,542, we get a total of 457.56. So the answer should be close to that. So we can automatically eliminate A, B, and D. C is the closest to the 458. All right. Now, even if you pick something like 17% or 16%, 458 would have been the one that is closest to that percentage. Okay. All right. Number 22. The Transportation Department has selected three possible routes for a new section of highway and wants to know which route landowners and residents of the affected areas prefer. The Transportation Department plans to survey the public by posting the 3 possible routes on the department's website with a request that all visitors to the website vote for their preferred route. In your answer document, explain why the design of the survey does not provide a representative sample of the landowners and residents of the affected area. Give an example of how the design of the survey could be changed to better represent the affected population. All right, if I were you, I would read that problem through a couple times. I'm not going to actually write out the solution here. We're just going to talk about it. So the reason why it does not provide a representative sample can be a couple reasons. Number one, some people might not have, that live in that area, they might not have internet access. Another reason, they say that they want all visitors to the website to vote. And what if a person comes to the website that is not living in that area? Okay, that's another reason why it's not representative. Let's see, other things that you might be able to say there. Because the survey is not advertised, people don't know to go to the website to vote. They didn't say that they were advertising it. So those are all good answers for the first part of this question. The second part says, give an example of how the design of the survey could be changed to better represent the affected population. Well, we could either start calling people and letting them know that they should make the survey or should take a survey online. You could do a mail-in survey instead. Oops, let me move that out the way. You could do a mail-in survey instead. That way you could get more of a response. You could actually go out and knock on people's doors and get a better response. Okay, so these are all alternative ways that you could possibly go ahead and make your survey a little bit more representative of the population. All right, number 32. Joel plays tic-tac-toe on his computer. The computer plays first and randomly places an X in one of the grid squares as labeled in the diagram. The frequency table shows the computer's first move for 50 games. Based on these results, what is the experimental probability that the computer will place an X in a corner square on the first move of its next game? Well, notice that the corner squares are here, A, C, G, and I. Those are the corner squares. And the number in the games, we had A was chosen 5 times, C was chosen 8, G was chosen 6 times, and I was chosen 7. Now, when you're talking about probability, we want to use this formula. The number of favorable outcomes divided by the total number of outcomes equals the probability. Well, in this scenario, the number of favorable outcomes is placing an X in a corner square. Okay, that's what we're looking for. Favorable outcomes is the outcomes that you're looking for. So if we add up the corner squares, 5, 8, 6, and 7, that adds up to a total of 26. And then we're doing this, and we're going to divide this by the total number of outcomes. Okay, and they told us at the beginning that this is for 50 games, and even if you added all of these numbers up, that all add up to 50. So the answer is 26 out of 50. Now, if you notice, that's not one of the solutions, but 26 over 50 does reduce to 13 over 25. All right, so our probability is 13/25. All right. Real quick, I do want to go ahead and make sure that you understand how to reduce fractions on the TI-30 X2S calculator, because this is the calculator that you will be using. Here, you would type in your number, and then you would hit the ABC key, and the ABC key is here. Okay, let me do a different color. Here's our ABC key. And then you would type in the denominator, then you would hit your enter, and after you type that in, your answer will come up to be something like this. So that means 13/25. Okay? Great. All right. Number 39. In honor of the new millennium, Stephanie buried a time capsule in her front yard. She sketched the location of key landmarks as shown below. She noted that the capsule was buried equidistant from the oak tree and the elm tree. It is also equidistant from the mailbox and the front door. So, which pair of coordinates is the closest estimate for the location of the time capsule? Well, let's just go ahead and go through each of our coordinates. So here we have 4 and G. So 4G. Does that look like it's equidistant from the oak tree and the elm tree? Not really. All right. So that was not our answer there. Let's look at the 7H. 7H, we go here 7, and then we have H here. So 7H, that's the point there. Does this look like it could be equidistant from the oak tree and the elm tree? Well, it's pretty close. It also says that it's equidistant from the mailbox. So from the mailbox and the front door. So that does look like it's pretty close. So I'm betting that the answer is going to be B here. Okay? But let's just go through and check the other points just to make sure. In fact, let's just go ahead and erase that. All right. So C, that says 8G. So 8G, that'd be here. Does that look like it could be equidistant from the oak tree and the elm tree? That's pretty close to the elm tree. So not that one. And lastly, we have 10H. So 10H is here. And that's really close to the elm tree and not close to the oak tree at all. Okay? So our answer, B, 7H. All right, 43. Jake's school awarded 450 raffle tickets as incentives. The principal will draw one winning ticket. The winner will receive a CD player. Drake received 3 tickets for good attendance, 5 for making the honor roll, and 2 for tutoring other students. What is the probability that one of Drake's tickets will be selected by the principal? Once again, we're going back to our definition of probability. The number of favorable outcomes divided by the total number of outcomes. Now, the number of favorable outcomes here is, because we're trying to find the probability of Jake's wins, is the total number of tickets that Jake has. He has 3 tickets for good attendance, 5 for the honor roll, and 2 for tutoring other students. So add that all up, Drake has a total of 10 tickets. And the total number of outcomes, the total number of tickets in the drawing, is 450. So answer is 10 out of 450. Once again, that answer is not up there. So we can reduce 10 over 450 to 1/45. So that would be our answer. Alright, great. Hope this video was helpful to you, and have a great day.